Welcome to Health Practitioner. Feeling sleepy after meals, brain fog, and low energy. These aren't signs of aging. They're your mitochondria crying for help. The latest 2025 research reveals diabetes begins when your cells run out of power. Some people say, my blood sugar is fine, but lately I feel so sleepy right after eating. My mind feels foggy and I'm just sluggish. Or, why is my stamina getting worse? My muscles seem to be wasting away so fast, I get winded just moving around, even though I'm not sick. These seemingly ordinary daily troubles might actually be early warning signals from your body. A review article published in Biomolecules and Biomedicine in 2025 explains this phenomenon. Diabetes actually begins when cellular energy goes wrong. Even more striking, studies published this year by the University of Michigan and Harvard University have further confirmed the crucial role mitochondria play in diabetes development. Let me first explain the core mechanism. Mitochondrial dysfunction, reactive oxygen species surge, and blood sugar metabolism abnormalities. These three cores form a vicious cycle, like a triangular spiral. And the symptoms we experience, easily tired, easily bloated, easily irritable, are actually early warning signs. First, let's understand what mitochondria are. Mitochondria are the power generators in our cells. Through a sophisticated system called the electron transport chain, they convert the food we eat into energy that cells can use, adenosine triphosphate, or ATP for short. When functioning normally, mitochondria help us produce sufficient energy to support high-energy consuming organs like the brain, muscles, and heart. But when we're chronically exposed to high sugar, excessive nutrition, or chronic inflammation, these mitochondria gradually lose their vitality. Research has found that when the electron transpo (RT) chain is damaged, a substance called NADH begins to accumulate. NADH is an important molecule in energy metabolism, but excess NADH causes two serious problems. First, it produces large amounts of reactive oxygen species free radicals. Second, it impairs normal fat oxidation. More importantly, mitochondria lose their original fusion repair mechanism. Healthy mitochondria fuse to supplement each other's energy and repair damage, and they also divide to eliminate damaged parts. But when this dynamic balance is disrupted, mitochondria become fragmented, unable to produce energy effectively, and generate large amounts of reactive oxygen species that further damage cellular DNA and proteins. It's like a motorcycle that was running fine suddenly gets bad fuel, worn parts, and a stuck engine. The whole operating efficiency drops dramatically. Even if it looks fine on the outside, it just won't run. Now let's talk about reactive oxygen species. Reactive oxygen species are actually a double-edged sword. Appropriate amounts of reactive oxygen species are beneficial to the body. They can enhance insulin sensitivity through redox regulation. But the problem lies in the amount. When mitochondrial function is impaired, reactive oxygen species production spirals out of control. Long-term exposure to high concentrations of reactive oxygen species leads to three serious consequences: insulin resistance, pancreatic beta cell dysfunction, and impaired glucose tolerance. In February 2025, a research team at the University of Michigan published an important finding in the top journal Science. They discovered that when mitochondrial function is impaired, it triggers a special cellular stress response. This response causes the beta cells in the pancreas, responsible for making insulin, to de-differentiate. Simply put, these cells become immature, stop making enough insulin, and even stop performing their beta cell functions. In May of the same year, the Harvard T.H. Chan School of Public Health also published another key study. They discovered a coenzyme Q metabolism defect in obese patients. Coenzyme Q is an indispensable molecule in the mitochondrial electron transport chain. When its metabolism goes wrong, it triggers an abnormal phenomenon called reverse electron transport, which causes mitochondria to produce more reactive oxygen species, further disrupting overall metabolic balance. These studies all point to one fact: diabetes doesn't start the day blood sugar gets high. It starts silently the moment mitochondria in the body become imbalanced. So when mitochondrial energy is insufficient and reactive oxygen species are excessive, what reactions does the body have? Actually, the body first shows a series of seemingly minor but actually crucial life symptoms. First is feeling sleepy after meals, brain fog, and unclear thinking. This is because the brain is an organ highly dependent on energy. When mitochondria produce insufficient energy, the brain enters power-saving mode. Second is poor stamina, slow exercise recovery, and rapid muscle loss. Muscle cells contain large amounts of mitochondria, and when their function declines, muscle metabolism and repair capacity also worsen. Third is easy constipation, bloating, and changes in stool odor. Intestinal motility requires energy support, and declining mitochondrial function affects the contraction ability of intestinal muscles. Fourth is slow wound healing, dry and itchy skin, and weakened immunity. Cell repair and immune responses all require large amounts of ATP support. Fifth is easily blurred vision or difficulty seeing at night. Retinal cells have one of the highest mitochondrial densities in the body and are particularly sensitive to energy changes. Sixth is emotional fluctuations, easily irritable or depressed. The synthesis of brain neurotransmitters requires sufficient cellular energy. These manifestations are like cells whispering, "I'm almost out of power, please help me." But in the past, we often only looked at blood sugar numbers and ignored these subtle but indicative life signals. Based on these research findings, I've compiled 5 suggestions that can be practiced in daily life. First, let cells catch their breath. Give mitochondria time to repair. Research shows that what mitochondria fear most is not work, but lack of rest. I recommend limiting calories or keeping a 12-hour fasting window each day. This is called nighttime intermittent fasting. This allows cells time to recycle damaged mitochondria through a repair process called mitophagy. Second, get moving but don't overdo it. Use motion to restart mitochondria. 15 minutes of brisk walking, climbing stairs, or marching in place each day. Just letting body temperature rise can activate mitochondrial biogenesis. This process activates a protein called PGC1A, which is the main regulator of mitochondrial generation. Exercise can substantially improve the body's energy state, but it doesn't need to be too intense. Third, post-meal walks help stabilize blood sugar and also help reduce reactive oxygen species. Research mentions that mitochondria produce large amounts of reactive oxygen species when blood sugar rises rapidly. Therefore, walking slowly for 15 minutes after meals is like helping to turn off overheated motors in the factory, avoiding metabolic overload. This is a simple but very effective habit. Fourth, choose the right nutrition and supplement in the right direction. Not all antioxidants can enter mitochondria. If you have a habit of nutritional supplementation, consider the following. Coenzyme Q10 helps with energy conversion and de-antioxidation, particularly beneficial for mitochondrial function. B vitamins support energy metabolism and are important cofactors for mitochondria to convert nutrients into ATP. Green tea polyphenols, blueberries, and dark green vegetables are natural antioxidant sources that help clear excess reactive oxygen species. Fifth, good sleep is the gentlest way to repair. Research clearly shows that sleep quality directly affects mitochondrial repair and reactive oxygen species metabolism. Reduce phone use and avoid sweets and fried foods before bed. Appropriate magnesium supplementation helps with sleep, which is like helping mitochondria turn off the lights and rest. Magnesium is a mineral essential for mitochondria to produce ATP, and adequate magnesium improves mitochondrial work efficiency. When we understand the truth, we can truly change. Diabetes doesn't start the day blood sugar gets high. It starts silently the moment mitochondria in the body become imbalanced. When we understand early that cells are tired and mitochondria are struggling, we have the opportunity to reignite cellular energy through daily life. It's not big changes that bring health, but starting with a post-meal walk or a cup of green tea. When you're willing to take care of your mitochondria, your body will naturally reward you in gentler ways. Thank you for watching Health Practitioner. See you next time.